So good morning. Usually at these sessions, the hardest ones to do are the ones right after lunch and then the early morning one on the last day because folks have been out, maybe enjoying themselves a bit. I celebrated a little bit last night because the Dallas Cowboys won and stayed up a little bit too late, but it is what it is. So let's get started. So first and foremost, right, this was going to be a joint presentation with one of my peers, my friend and colleague, Vibhor Kumar. Unfortunately, Vibhor couldn't make it. He had some family issues he had to take care of back in India, so you're stuck with me. So Vibhor heads up our performance engineering team, and in my opinion, he's one of the brilliant minds that we have on staff here at EDB, even though he kind of did leave me hanging for this particular presentation. But Vibhor and his team just continue to push the envelope of what Postgres can really do for our customers. So today we're going to talk about the evolution of Postgres replication high availability. So in my role at EDB, I'm a field CTO, and I have the opportunity to work with some of our largest customers, many of which are running mission-critical applications on Postgres. So that'll be kind of my perspective for this presentation today, a part of my perspective. The other part of my perspective will be from the business side of things, how these topics, replication and high availability, are important to businesses and that businesses that you guys probably support on a day in and day out basis, whether you're an employee, whether you're a vendor, or whether you're a consultant to that business. So why that perspective? Mainly because that's my background, right? And that's what I know. Although I've made a living working in IT, I'm not formally trained in computer science. That's not my degree. My undergrad degree is in finance and HR, and I have a master's degree in business administration. However, I've worked in IT as an employee, as a consultant, as a vendor for most of my adult life, right? In various roles from development, data integration, data governance, I can't even pronounce it, and implementing databases and data strategy. So what I always found, though, that was interesting, what intrigued me, is how do you take your IT initiatives and objectives and start to mesh those with the business objectives that the line of business has for the organization as a whole. And I think that intersection of IT initiatives and business objectives is really where we can make stuff happen. And usually that's where the funding is, right? So that's important as well. But this requires us to focus on the evolution and change of the process. And there's a quote by one of the Greek philosophers, Heraclitus, and it's one of my favorite. I often use it with my kids, is the only constant in change is life. Now, usually my kids couple that with, yeah, and change is frickin' hard, Dad. And I would agree that change at times is very hard. But nonetheless, it's something that we have to deal with. And if you guys listened to Bruce's presentation yesterday on Will Postgres Live Forever, you heard that when companies fail to innovate or fail to embrace that change, then they ultimately fall by the wayside. So none of us, I don't think, want to see that happen to the organizations that we work for. So today we're going to talk about the evolution of replication high availability. We're going to talk about some replication solutions that you may see out in the field or out in the wild. We're going to talk about always on, right, and that paradigm shift, and why we feel that is the next evolutionary step. And as a bonus, we're going to talk about how that always on architecture can be utilized as an alternative to Oracle RAC in certain situations. So the objective of this session is really to explore the evolution of Postgres replication high availability and how you can better service your ultimate end consumer by understanding the paradigm shifts that are driving these changes. So key takeaways from this, Postgres replication has evolved, and it's evolved based on the requirements of the business, right? And what they're dictating. That evolution continues to drive many business critical applications to require and dictate near zero downtime, or what we refer to as always on. And thirdly, right, you can achieve, your organization can achieve near zero downtime, or 5 nines of availability for your most demanding business applications if you need it. Now, we're not going to go into detail on what 5 nines mean and 4 nines mean in this presentation. Actually, I'm going to put a plug in for one of my peers, a fellow field CTO, Leticia Avero, and she has a presentation later today entitled Chasing Unicorns, right? 0 data loss and 99.999% availability, where she's going to explore what has to fall in place in order to achieve 5 nines of availability and whether that's realistically possible. And she's going to go into detail around what it means by 5 nines and 4 nines to the business, and how do you achieve those. So let's get into it. Evolution of replication. So it seems I do a lot of these evolution slides. I did our presentation. I did one for a customer that was really the evolution of performance improvements within Postgres throughout the various versions. And I always kind of laugh at these cartoons or these depictions of evolution, and especially this one, because we've kind of evolved to being reliant and dependent on technology as a culture and as a human race. So it is what it is, right? So replication is used for many reasons, right? Disaster recovery. It may be used for read-write scaling, possibly to offload reporting from a production database. It's used for backups, and most relevant to this kind of presentation, it's used for high availability and failover. So as replication and as a result, high availability continues to evolve through various technologies and capabilities, the demands of the business also continue to evolve, right? High availability used to really refer to technologies that protected the software from hardware and network failures. Here's where that paradigm shift really comes into play. Due to changes in our culture, right, where my wife, more than I, but you can order something off of Amazon and have it delivered today, right, potentially, at the latest tomorrow. So that the consumer's paradigm of what availability means to them has really shifted. So we also see that business's paradigm of availability has also shifted. And society no longer, really tolerates that delayed gratification. Is we got to have it now, right? We got to have access to our website, to our bank account, to all of these systems immediately. And as a result, today, high availability really refers to service availability. Today's definition is really independent of that hardware and software component, hardware and network component, or even the software component failing. HA now has to take into account disruptions, right? Whether they're planned or unplanned to the process, and deal with those and provide that uptime for their ultimate consumer. That means that maintenance windows for the operating system or the OS or the database patching are really kind of diminishing or vanishing. And planned maintenance really is becoming, or those planned maintenance windows are really becoming a thing of the past. And our customers are asking the questions, how can I do these things that I have to do to maintain my system while keeping it online and available for my customers and my end consumers? So we really believe that always on, and we'll talk about what that means later on, is really the next evolutionary step, and that's driven by the need of that zero or near zero downtime that the businesses are demanding. So if you look at this timeline, it really summarizes the work that's been done over the years to add capabilities to Postgres and to make replication, which replication ultimately is the way you implement high availability. It makes replication work better. So the first generation of replication tools, whether that be, Londas, Bucardo, Sloaney, were really add-ons to Postgres and not built into Postgres directly. Nevertheless, these were important contributors and products in the overall evolution of Postgres and replication itself, right? And then came kind of streaming replication. This was really an evolution of log shipping, and log shipping was introduced around version 8.3, I believe, and streaming replication was actually introduced in Postgres 9. Then you had hot standbys, right? These are standbys that are always in play, and they're enabled by synchronous and asynchronous replication. Whoops. Next, you have lost access to my slides. There we go. Right. So next, you have logical replication. And this is really, an important step in the overall. All right, there's my mouse. There we go. So the big thing about logical replication is that you can replicate across versions, right? Not just minor versions, but major versions potentially, where streaming replication required you to be on that same major version 9, version 10, version 11, right? Whatever dot release. So as you can see, or as you can start to see, logical replication starts to enable upgrades without taking the servers down if you have your system designed or architected in a cluster, right? And we can't forget about DDL replication. This is important because as many companies start to adopt agile development, there are always changes to the underlying database and the structure, and being able to replicate that DDL has really become a requirement for many of our consumers. So you can really start to see that the evolution of these products, features, and functions have contributed to Postgres and really made our replication story more and more powerful over the years. So let's take a look at some common replication solutions that you may have encountered in the field, right? You may have even implemented some of these on your own. You may be familiar with them just by name recognition. These are not all the options. I mean, let's face it, I got 50 minutes here, so I can't go through every single option. But these are some interesting ones that have some advantages and disadvantages and that we've seen in the field. So I mentioned Bucardo as one of the first generation, along with Sloaney and Londas. And we're going to briefly touch on Bucardo, but I thought I'd bring up an issue that I have with one of my largest customers that I support, is that they're utilizing Sloaney and they're currently seeking a better alternative, right? Sloaney's kind of dated. It requires a lot of just hand-holding and maintenance. And they're looking for the replacement. And the interesting part about the way they've implemented Sloaney is, for my particular customer, is they're using it to support rolling upgrades. And that's really important to them from a maintenance, patching, and upgrade perspective. So anyway, that aside, let's move into Bucardo. So anybody in the room familiar or utilize or implement Bucardo? All right. So I can say whatever I want, but no, in reality, Bucardo was released publicly in 2007. Development started, obviously sometime ahead of that. It's a standalone replication system that supports several platforms. You can push to and from Postgres and to other databases. It supports both master and slave, as well as multi-master, and has kind of built-in custom conflict management. That becomes important as you start to move into multi-master, because you can have conflicting data entries, and how do you resolve that in a reasonable fashion. Kind of some of the downsides to Bucardo is it's trigger-based, and this can have introduce overhead on the database itself and can be slow at times. And the process that they've implemented is only asynchronous. This doesn't support DDL changes, right? And I mentioned that a lot of our customers, and probably a lot of your customers, this is important to them as they look to the future. It doesn't have direct support for sequences. This becomes important, and we'll talk about it probably in more detail later, but when you're in a multi-master distributed system, you have to be able to manage sequences so that they don't step on each other, right, and you don't have conflict. So, and the best I can tell from what I looked up and researched, the last update to Bucardo was in February 2021, so you know, it's been well over or close to a year at this point, right? So, SymmetricDS. Anybody familiar with Symmetric? Nope. Either that or you guys are just sleeping, but either way. So you gotta love, you know, the marketing guys. They say a lot of stuff, but they don't really say anything, right? So from Symmetric's website, it says they're a fast and flexible database replication. SymmetricDS is open source database, right, which is important to many of us. So open source database replication software that focuses on features and cross-platform compatibility. Okay, so what does that really mean, right? So they're open source, and they have a Java-based source code. And that code base has evolved really over the last 10 years, and it appears to be very mature in the marketplace. It's very versatile. It supports a whole litany of databases from Oracle, MySQL, Maria, Postgres, SQL Server, DB2, Greenplum, even Mongo, Sybase, right? And there's others. So it has a lot of capability. It is multi-master capable. It does have the conflict management, which is important, as well as custom event notifications. They do offer a professional edition as well that is supported outside of the community. So you pay a subscription to that, and you have additional support for that product. The downside is there's a steep learning curve, right? Just due to that extreme flexibility and the capability to connect to all those databases. And it comes with a pretty complex topology and architecture deployment. It's also trigger-based, right, which, as I mentioned, increases overhead, and this requires an event table, right, so it can track changes. And while it's multi-master capable, it's really not multi-master native, and it has issues merging data back together when you're dealing with conflicts in a multi-master scenario. So, Quest Shareplex. Their website says they're the golden alternative. So golden is probably the key word in this, right? They're the golden alternative for database replication to achieve high availability, scalability, and near real-time data integration. The reason that I think they use golden is they are positioning themselves as an alternative to Golden Gate, right? These guys are very focused on Oracle. They do other databases, but you can see just from their marketing material, their website, and how they position themselves that they're looking to go after that Oracle space. They're not open source, right? So for many of us and many of our customers, that's their strategy. So that's a negative for them. It's based on logical replication, has kind of all of these cool features that it provides. And it can also be used as a high availability failover management tool. So Postgres Replication Server by EDB, right, which is who I work for. So from our website, EDB Postgres Replication Server, so before I continue, anybody using our EDB's replication server? Wow, tough crowd. What do you guys use it for replication? We'll get back to that. But it provides a robust, from the website again, marketing guys, a robust data platform that replicates between Postgres databases in a single master or multi-master mode, and from non-Postgres databases to Postgres, so from Oracle or SQL Server, right, in a single master mode. So It really supports two-way logical replication, right, which is another way to say MMR or multi-master for Postgres and EDB Advanced Server. And it supports one-way logical or SMR, single master replication, to from non-Postgres databases to Postgres. So that SMR use case, right, that single master replication is really the foundation that we've built into our migration toolkit. So when we migrate customers from Oracle to EDB Advanced Server, which is Oracle compatible, we use basically replication server under the covers of our migration toolkit to accomplish that. It utilizes a hub and spoke model with replication server as kind of that hub and the databases as the spoke. Typically, you know, it's deployed on the same server as a database, so you're not using additional hardware. The cons are when you go from non-Postgres databases, it requires you to use trigger mode, right? And this requires 3 triggers, right? An insert, an update, and a delete to be populated on the publication table. And it also requires a shadow copy of that table. And you must utilize, you know, the tool to configure and apply DDL changes. So Oracle Golden Gate, right? If Postgres is the elephant in the room, then Oracle and Oracle Golden Gate is really the 800-pound gorilla that's in the room. Just they're, you know, they are what they are. So, you know, we'll start with the cons because, you know, Oracle is a sworn enemy of many folks that are in the Postgres community, and many of our customers are looking to reduce their costs of Oracle, and so that's really negative for those guys because this can be a costly solution. The benefit is, since it's, you know, Oracle and since it's costly, you can kind of expect that you're going to have Oracle support and you know, hold their feet to the fire because you're paying for this this service. It's a fully matured product that has multiple options to replicate. It supports heterogeneous database replication. It has customizable conflict detection. It also, there's a Oracle Golden Gate cloud service that allows you to replicate from Oracle into your cloud provider database, right? So that's a new service that they've come up with. And they have a data validation tool called Golden Gate Veridata that allows you to validate, you know, source and target data to make sure they're in sync. So I talked to one of our guys, one of our SEs is very deep in Oracle. He's previously Oracle DBA. And I said, you know, what can you tell me about Golden Gate, right? First thing he said is it's complex, right? When you build this conflict detection, it comes with a level of complexity. And if you know how to do it, it's not easy to translate that to others on how they can maintain and make this sustainable. So not many people in the community from a DBA perspective can really support that conflict detection. The other thing that he says that's really not apparent until you start using it is due to them having to replay each transaction, their logical replication can be slow at times. So those were kind of directly from someone that's used the product on a regular basis in the past. Right, so you may ask, right, what about Postgres native logical replication, right? Isn't that sufficient, right? Is it going to get the job done for you? Is anybody using that in your environment? All right, I see a couple hands go up, so good. So a lot of folks use it, right? And you know, if it can meet the need, then why not? But out of the box, it doesn't do DDL replication, which is what we're hearing from some of our larger customers. That's important for them, along with the high availability. And there's really no failover mechanism built into, you know, native Postgres logical replication. And there's no built-in procedures for you to kind of do that maintenance and that update or upgrades, right? So you can build that, right? And we have a lot of smart people working for our organizations, you know, you guys in the community, and you can make it do all of that, but how do you make it sustainable? How do you make it supportable when you build that? Is it something your organization is going to stake their business on by having a homegrown solution built on logical replication? And so many consumers are trying to use it as a building block to create a more holistic solution, but out of the box, right? And I guess the main thing is it's not a great HA solution directly out of the box without some additional work on your part. So that brings us to Postgres-BDR. Anybody familiar with Postgres-BDR? Have you heard of it? All right. So you've heard of it? Anybody have it implemented in their environment? No. Okay. So BDR is bi-directional replication, and this was developed by the fine folks at Second Quadrant. Second Quadrant is actually part of EDB now. We acquired them, last year, or roughly this time, right? They became part of our organization. So BDR builds upon logical replication and does that in a mesh network and multi-master. It does add that automatic DDL as well as DML replication in an active-active mesh network. It has built-in failover and switchover to be able to reroute that traffic without human intervention in case of failures. And this is important not only if you do maintenance operations, right? You take, and we'll go into the architecture in a bit, but if you take one of the servers, one of the nodes out of the cluster to do maintenance on it, whether it be an upgrade, a patch, or whatever, it'll reroute to the other nodes in the server. Or worst case scenario, that node fails, right? Hardware failure, network failure, whatever, it doesn't have access. Then it can reroute the application request to the available servers. It has advanced conflict detection and conflict management. And this is really critical when you have a multi-master scenario with many nodes participating in the cluster. It has management of distributed sequences. And again, this is important, right? If you've got multiple clusters in the node and all of those are the application is requesting an insert and you need to apply a sequence to that insert automatically, how do you manage that without stepping on each other across those nodes? So BDR has that facility to be able to do that. It has differentiated replication sets to really control which data gets replicated to which downstream databases. BDR, one of the cool things is BDR supports rolling software upgrades. Simon Riggs, who was the CEO of Second Quadrant, did a webinar recently on how you can use BDR for rolling upgrades. So I would really encourage you guys to, if you're interested in that particular feature, to go out and find that webinar on EDB's website, and it'll go into a lot of detail on what that is. So Postgres-BDR really builds on logical replication, right, as a framework, and expands the capabilities of Postgres to create a tool that can have extreme availability, right? Those 5 nines of availability are what we've kind of coined as an always-on concept that I talked about previously. So let's kind of talk about that always-on, right? So we'll look at it from 2 perspectives, right? Historically, high availability, as I mentioned before, defines systems that are protected against hardware and network and software failures. But this assumed, at least in the past, that there was a maintenance window, right? If you guys are DBAs or ever worked in that environment, it was maybe the 3rd Sunday of every month, right? Or whatever that cadence was, there was a maintenance window where things could happen on the database and the database got taken offline, right? So several tools exist to kind of facilitate the old school high availability, whether that be EDB failover manager, rep manager, Patroni, all of these kind of rely on physical streaming replication. Always on is really that new business paradigm and imperative that I mentioned in the beginning. And like high availability, always on protects against failures, but the main difference is that there's no need or no requirement for that maintenance window, right? Patches, upgrades are applied to the system while it's up and running, so you can really start to strive for that target of 5 nines or availability or 4 nines or availability or whatever your business requirement is, but it allows you to be able to achieve that by not having to take your systems completely offline to do maintenance. So there's a poll that was done by ITIC, right? They have a reliability poll. And so they asked customers basically, how important is always on? Or what does it cost you potentially when you have system downtime? And 4 nines of availability is kind of the standard today that they saw. And downtime not only costs dollars and cents, right, for the business, but it can also cause a loss of customers. Think about credit card, right? I get so frustrated when I go to swipe my card and it gets rejected, right? It's pretty embarrassing for one. And then I immediately have a thought that my wife has overspent on Amazon that I mentioned earlier, and we got a challenge from that perspective. But usually it's neither of those, and it's just because it doesn't have availability, right? Either something's going on in that overall network that doesn't allow my credit card to get processed. So I stick it in again, and I get rejected again. So now the embarrassment is even more, and that credit card then quickly goes to the back of my wallet until I resolve what the issue is, and I start using another one, or I just completely get rid of it entirely. So that could potentially cost that credit card provider business, right? They could lose my business, but they're losing that transaction costs that they incur or they get from that credit card swipe. So that's just one example, but I'm not sure who they surveyed in this, but 88% of the firms surveyed say that a cost of a single hour of downtime could exceed $300,000, right? So when you start putting numbers like that to your business and asking them, what does it cost when applications can't do what they need to do because they don't have connection to the database, it really starts to become, apparent that this high availability and this always on is really critical to a lot of our business applications. Right, so let's talk about the architecture of BDR, right? This is our platinum architecture, so this is the Cadillac of our architectures. All of the others, we have a total of 4. We have a bronze, we have a silver, we have a gold, and we have a platinum, are really derivatives of this architecture. It just, as you move down the stack or down the options, we take things away, right? So you start to make compromises as you choose a lesser architecture. For example, when you go from platinum to gold, you eliminate the logical standby. And you're like, well, all right, what does that mean? Well, the logical standby really allows you to have high availability or maintain high availability within a data center, because let's say the BDR node 2 on the left in that data center goes down, you can take your logical standby and immediately replace BDR node 2 with the logical standby, and you still maintain high availability within that data center. In the gold architecture, without a logical standby, you don't have that luxury, right, to replace BDR node 2 with your logical standby. So for some period of time, however long it takes you to rebuild BDR node 2 and replicate that data back to it, you're flying without high availability in that particular data center. You still have your second data center, but for certain customers, that's important. And then as you move down the stack to bronze and silver, you have other compromises. And we can go into more detail offline if you guys want to talk about that. But we'll use this as an example. to talk about the capabilities and some failover scenarios of BDR and how it handles it. So first and foremost, you have the application coming in right on the left-hand side. The application connects to the system, right, to the BDR system, using a multi-host connection string. And this allows rapid failover because we have two pairs of PG bouncer and HA proxy for high availability and failover on that particular aspect of BDR. So PG bouncer, you guys are familiar with that, I'm sure, provides connection pooling for the environment. And HA proxy really provides that connection routing along with HARP, which is our high availability routing protocol, to allow for the application to have their request routed to the appropriate server that is the lead master at that point in time. So we have, if you look, we have multiple databases in this architecture. We talked about a mesh architecture where every database is replicated to the other databases. So the lead master is the Postgres server that is taking the request from the application if it's available. So it receives write and read requests from the application, and it replicates those to all the other nodes within the cluster. The shadow master is there. It's read-write enabled, and it's there to continuously receive replication from the lead master and all the other BDR nodes. But in case of failure or switchover, the shadow master can take over immediately and become the lead master servicing your applications, right? We have the logical standby that I mentioned earlier. This is a read-only node, and it's replicated from the shadow master, and it can be used for offloading read transactions, but its primary role, as I mentioned earlier, is in case of hardware failure on one of the lead master or the shadow master, so it can be a replacement for those. We have Barman up in the top there, and you might ask, right, I have all these copies of the database, why do I need backup and recovery? I got, in this scenario, at least 6 copies of the database. So why do I need Barman? Well, what happens if, I say delete table and then quickly realize, man, I really did not want to do that. Well, I deleted it from the lead master BDR node 1, and it quickly replicated that change across all the nodes. So now that table that I really didn't want to delete is now cascaded, deleted across all of the BDR nodes. And you're like, well, what do we do now? So with Barman, you can go back and recover that table. And customers ask, do I have to have Barman? No, you don't have to. You don't have to do anything. But it's strongly recommended for those, man, I wish I didn't do that type of scenarios where you delete a table. So that's available. And then we have the witness node, and that's typically in a third data center. And it's there to provide consensus and quorum in cases of data center failure, so you can handle that. And then underneath all of this, which is not depicted necessarily in this chart, is a process or a tool called TPA exec. And that's really the tool that allows you to deploy and consistently deploy, and that's important, consistently deploy and operationally manage these trusted Postgres architectures. So that's what TPA stands for, is trusted Postgres architectures. So that's there. So let's talk about some scenarios, right? What happens when when the lead master fails, right? There's a hardware failure, and that guy's just poof, no longer available. So HARP kind of detects that that node has failed, and it switches the PG bouncer HA proxy pair to now route traffic to the shadow master, right? So one of the questions we always ask customers when we start talking about the applications is, what is your retry strategy for that application? Because you're going to have, if you have a transaction that's connecting to that lead master and it goes away, then obviously it's going to create some issues with the connection, right, that are in flight. So do they have retry capabilities within the application? And how does that work? And what impact does that have on the downstream consumer? So that's kind of something you need to think about. But the shadow master pretty much immediately takes over and starts processing, and it's replicating to the others in the cluster. And then as either you promote the logical standby to be the lead master, or you get that lead master back up and running, then it becomes another active member in the node after it catches up with the replication. So let's talk about the scenario where it doesn't just go away unexpectedly, but you want to do maintenance on the lead master, right? You want to apply a patch, you want to do an upgrade, you need to do something on the operating system. So in that scenario, you can take it down a little bit more gracefully, right? So you can use TPA exec to kind of drain off connections from, well, start routing net new connections to the shadow master, and then start bleeding off the connections that are on the lead master. And once all of those connections are satisfied, then you can take that one offline, do whatever you need to do, and the application is none the wiser. You do your patch, you do your upgrade, you do your OS, whatever, and you bring it back online, it catches up through replication, and then becomes the lead master again. So that's pretty seamless. So what happens if you lose PG bouncer or HA proxy, right? Well, the good thing is we have two pairs of those, right? So due to using the multi-host connection string, the application is pretty much going to be none the wiser, right, when that happens, and you can work through that, right? So what happens if we lose a whole data center? And it happens, man. I had that customer that I talked about that's on Saloni this winter, right? Because I'm in Texas. We had a bad winter in Texas where we actually had multiple days below freezing concurrently, and this customer, their data center lost power because of the power outages, and the backup generator didn't kick in, and they lost their data center. So it happens. So if you have the second data center, right, then you're kind of covered. The management plane of the application will either redirect, right, if your application's over here, will either redirect, right, and we kind of push this back on the application, redirect to the other data center, or more than likely, right, if the applications live in that same data center, they've died as well, right? So then the other data center just comes online, and it's handled from that perspective. And that's probably the preferred path, is don't have the applications traverse across geography and data centers, and just switch over completely to that data center until you get your problem resolved. So, whoops. That's not good. Okay. So let's talk about how this architecture has the added benefit of potentially being a replacement for Oracle RAC, and why that may be important for your larger customers. So let's look at Oracle RAC in comparison to BDR, and you'll start to see some nuances and differences, right? As we compare BDR to, Oracle calls their RAC their maximum availability architectures. They have 3, we have 4, so that's, I guess, the first basis of comparison. But if you look at Oracle RAC, they have a shared storage layer, right? If you look at BDR, BDR has shared nothing. Every BDR node has a copy of the database. So that's good. I've had customers push back, say, yeah, but now my disk requirements have gone up exponentially. True, but it's potentially a price that you pay to have this always-on architecture in a Postgres implementation. And we would argue, and my friend Tom Kincaid, who stepped in the room when he first started talking to me about BDR, he said, look at Oracle RAC. what do you see as a potential single point of failure right in that data center? And can anybody kind of see what that potentially would be? Yeah, the storage layer, right? So you lose that storage layer and effectively you've lost a data center, right? So that's something that Oracle doesn't really like to talk about when they talk about their Oracle RAC implementations. So BDR can run on commodity hardware. It doesn't really benefit or require the hardware that, the requirements that Oracle dictates for RAC, right? SAN storage and things of that nature. We can use it, but it's not an absolute requirement. BDR can run on all public clouds, right? Versus Oracle RAC can only run on the Oracle cloud. So think of the problem that customers are having. They're trying to reduce their costs with Oracle because it's expensive, and their initiative is to move to the cloud. But if they want to move to the cloud with Oracle RAC, their only option is Oracle Cloud. So it becomes a vicious cycle of I'm trying to get off, but I have no option to do anything. And how do I get out of this hamster wheel that I'm on with Oracle? So with BDR, we can deploy on all public clouds. So we kind of position that as our alternative, or we are an alternative to Oracle RAC, especially if you're going to the cloud. And I'm working with a big telecom provider involved in the pilot and POC, where they're looking to move their entire Oracle estate off of Postgres and off of Oracle and out of the data center to the cloud, and they're looking at Postgres. And so they're confident that Postgres can handle their workload, but they're like, but we got one gotcha. How do you handle RAC? Because we have RAC implementations in our environment. And our answer was, finally, BDR, right? We can satisfy their requirements with BDR and move to the cloud. So with luck, we'll complete that, and we'll have a net new customer utilizing BDR on the cloud. So we're not necessarily a direct replacement for every scenario that Oracle RAC sells for. And that same guy, our SE that's deep in Oracle and was an Oracle DBA previously, I was talking to him about Oracle RAC and how prevalent it is and why customers really move to Oracle RAC. And he said, to be honest, he's seen scenarios where the DBAs wanted experience with Oracle RAC. So they just said, hey, we need it, and they deployed it, and there was really no sound business case for it. So now that database is probably sitting out there, and some executive or director is struggling with, how do I get rid of this Oracle RAC? And there's really no need for it. So many times when we look at why customers are using RAC, they can move off of RAC and move to a Postgres implementation that's non-BDR potentially, and still satisfy the same requirements that they were getting with that particular database. So it's always interesting to see the dynamics of the reasons and the choices that customers have made in the past. So kind of wrapping it up, because I think I might be over. Let's try to land this plane and wrap it up. So business needs, right? And I talk about that intersection of business and IT is really where we can have a huge impact. The business needs are dictating a paradigm shift in how HA is defined and really how it's implemented. There are options that you have for replication in HA, but none can really achieve that extreme availability or always on that Postgres-BDR has. So if that's one of your requirements, then obviously we would encourage you to look deeper into what BDR has to offer. And BDR can be architected to achieve 5 nines of availability if that's your requirement, and more importantly, can be seen as an alternative to RAC for on-premise, but also, and probably more importantly, as customers look to vacate the data center and move to the cloud, then BDR can be seen as an alternative for RAC implementations. So that's all I have. I want to thank you guys for your time.